In this video, we're going to look at graphing quadratic equations. The graph of a quadratic equation written in the form y is equal to ax squared plus bx plus c, where a, b, and c are all real numbers and a does not equal 0, is called a parabola. First, let's graph the function y is equal to x squared using a table of values. Examining this function, we can look at a spread of values from -3 up to +3, all by increments of 1. Calculating the corresponding y values, remember that y is equal to x squared, so we have -3 squared, which is 9, minus 2 squared, which is 4, then we get +1, 0, 1, 4, and 9. Now graphing these values on our x, we have our x and y axis. Start off with our vertex at 0, 0. Then we have 1, 1, -1, 1, 2, +4, and -2, +4, as well as 3, 9, and -3, 9. So we can see here how symmetric, perfectly symmetric. I mean, if it was drawn by computer and not by hand, it would look much better, but we have the graph of y is equal to x squared. So we can label a few things here. This is called your vertex. In this case, our vertex is a minimum because our parabola opens up. This parabola also only has a single root, and that root occurs at 0, 0, so the same as the vertex. And we know the parabola opens up because its a value is 1, which is positive. This parabola also has an axis of symmetry, so a line, vertical line, that can divide my graph in half, and if you were to fold the paper in half right at the y-axis for this particular graph, you would find that the two sides of the graph overlap. Now we want to take our general knowledge of the graph of the equation y is equal to x squared and apply it to various transformations of the general parabola. Given the quadratic equation either in general form, where we have ax squared plus bx plus c, or in vertex form, a multiplied by x minus p squared plus q, we have a vertex that's located at pq, and we can find those p and q values from our general equation as -b over 2a, and then by substituting in that x value into the equation, so we have it shown with function notation here, as well as the axis of symmetry, which is the line that divides our parabola in half, and that is given by -b over 2a. There's key information that we can gain from the equation of the parabola and apply it to our transformations by describing the vertical shift, horizontal shift, direction of opening, and stretch or compression. The value of q indicates the vertical shift, and that vertical shift will either be up or down. When q is positive, there's a vertical shift up, and when q is negative, there's a vertical shift down. The horizontal shift is given by the value of p. If p is positive, then the shift is to the right by p units, and if p is negative, then we move to the left by p units. The direction of opening is given by variable a. If a is positive, then the parabola opens up and the vertex is a minimum, and if a is negative, then the parabola opens down and the vertex is a maximum. The magnitude of a, which is a in absolute values, indicates whether or not we have a stretch or a compression. If the absolute value of a is greater than 1, then we have a stretch, whereas if the absolute value of a is less than 1, we have a compression. The stretch and compression described here are vertical stretches and compressions. So let's practice using a few examples. We want to identify the key features of the graph as well as actually graph them. First, we want to graph y is equal to x minus 2 squared plus 1. Right away, we can identify that this parabola opens up and it has a vertex at the point positive 2, positive 1. So the reason we know that it opens up is that our a value is 1 and 1 is greater than 0. And since a is equal to 1, there's no vertical stretch or compression. It just follows the regular step pattern to graph our parabola. So let's start at the vertex. We'll plot the point 2, 1. So identifying our x and y axis, we can plot the rest of this graph. So we know that it opens up. Our next point will be over 1, up 1 from the vertex and in both directions. And then to find the next point, it's over 2, up 4. And lastly, will be over 3 and up 9. Now we can plot this parabola. And you can confirm each of these graphs by comparing them to a graph using Desmos. So this is y is equal to x minus 2 squared plus 1. That equation was given to us in vertex form already, but sometimes you may be given the equation in general form, and you would want to complete the square and place it in vertex form before graphing. In question 2, we're given the general equation of a quadratic function, y is equal to 2x squared minus 4x, to graph it by first finding the vertex. The first step to find the vertex is to put it into vertex form by completing the square. We want to factor out the 2, and we're left with x squared minus 2x. You still have a plus 5 on the outside. We would need to figure out what we need to add to complete the square. And so we have x squared minus 2x. To find that last term, we divide the negative 2 by 2 and square it. So we end up getting plus 1. Now, we've really added in 2 times positive 1, so we need to subtract 2 times positive 1 in order to balance the equation. Now, this factors as x minus 1 squared, and the constant on the outside, so we have minus 2 plus 5 simplifies to positive 3. Therefore, we have a vertex at the point 1, 3. Our value for a is 2, which is greater than 0. Therefore, our parabola opens up. And we have a stretch. So because the absolute value of a is equal to 2, which is greater than 1, we have a vertical stretch by a factor of 2. So what that means is that for each increase in 1 unit in the x value, every typical increase for y will be double. So let's start by graphing the vertex. We have the point 1, 3 as our vertex, and we know that our parabola opens up and we have a stretch by a factor of 2. So if we go over 1 unit, we're now going to go up 2. Going on the other side, because we have that axis of symmetry that goes down the line x is equal to 1. Then we also can see that if we have an increase in 2 from our vertex to the right, instead of going up by 4, we're going to go up by 8 units. It should be positive 11. And anything else I graph here is going to go off the graph, but it will increase very quickly. And we have the graph y is equal to 2x squared minus 4x plus 5. You can write the general equation or the equation in factored form. So a few other things to note: our axis of symmetry is x is equal to 1 and runs right down the center of the parabola. And the domain of this parabola is all values of x. We can put any value of x into the function, whereas the range is y greater than or equal to 3. We have one more example. It says graph negative x squared plus 6x. And what we can do here, there's a couple different things. We can identify the roots. If we wanted to do that, we can see from looking at it quickly that our roots will be 0 and positive 6. And you could solve for that by factoring. But if we want to find the vertex, we should put it into vertex form first. First step is to factor out the -1, and we're left with x squared minus 6x. In order to complete the square, we need to add 9. Okay, remember, if you add 9, we also have to subtract out -1 times 9. So that -1 comes from the -1 outside. And because we added 9 in, we have to subtract the same value. Now, this simplifies to negative x minus 3 squared plus 9. Therefore, we can identify our vertex. Positive 3, positive 9, and our parabola opens down. And the absolute value of A is equal to the absolute value of -1, which is just positive 1. Therefore, there's no stretch or compression. Let's graph it by starting at our vertex. We go up to 3, positive 9. Because there's no stretch or compression, we know that it follows the same step pattern as our y equals x squared graph, except for because it opens down, it's gonna, each of the step will be in the downward direction. So over 1, down 1, over 2, down 4, over 3, down 9, and see, we do have our roots of 0, x equals, and x equals 6. And now we can connect these points with a nice smooth curve that goes through each of these points, and it gives us an approximate graph for y is equal to minus x squared plus 6x. The domain of this graph would be all values of x, and the range would be y less than or equal to positive 9. Can also note that we have an axis of symmetry that is x is equal to positive 3. So this example concludes our videos on quadratic functions. As always, make sure that you try the recommended homework and contact your instructor if you have any questions. Take care.